Hi, welcome to Memory Built-in Self-Test course. In this course, I'm going to teach about what is the testing of memory in the chip design process, why we do it, how we do it, and I will share all details about that one. So the motive behind development of this course was because when I was starting DFT, there was not many material which I could refer to learn about memory testing. So this is like one of the wish at that time I had, that I really wanted some course which covered the basics about memory built-in self-test, like why we do memory testing, what are the basic components, and what are the reasons, how we do it. So that's the main motive behind development of this course. So other than that, because in the chip design process, the complexity is too high. So we have to touch up different areas, especially during DFT. So when we are doing the design for test process for any chip, we have to touch up the RTL process. Like we have to make sure our RTL is clean. We have to go through synthesis process because that's where our DFT logic becomes like in the gate form, in the synthesized form. Then we also need to see the physical aspect because a chip can have a lot of memory. So we need to see physical aspect, that where different memories will be placed, where different flip-flops, different IPs, different analog blocks will be placed. So that is also important part. And we also need to make sure STA for static timing analysis, that our DFT timing can meet the timing, like at which frequency we will do testing. That's also important. And then we also have to touch up with silicon bring up. So in silicon bring up, and we have got the tape out chip. Now we need to do testing of the chip. So we need to make sure that everything can run smoothly and the chips can be tested properly in the production stage. So the complexity is quite high for DFT in the chip design process. And then for academic exposure, because I have been coming from like academia, like I used to study, so there is almost next to zero exposure. Like there will be almost no touch up on DFT, and there is no information about especially memory based, like in details, like what kind of tools we use, how we use, what is the flow. That thing is totally missing in the courses mostly. And in academia, mostly the focus is on the digital design, RTL coding, as you know, like you have seen, I have seen. So, and we are learning a lot about analog blocks, how we design them, and then we are learning about CMOS layouts. But mostly we are missing the DFT part in academia. If you come towards industry, and if you are a new person in the industry, then you may notice that in your company, in your organization, there will be a lot of tools being used for DFT, and which will make you confused, like why we use so many tools and what is the purpose of different tools. Why we are using tool A in the start and then we use tool B and then suddenly we jump back to tool A. So this makes new people more confused. Like I used to be so confused when I was doing DFT in the start, and I was like, why there are so many tools and what is the purpose of each tool and why we are jumping between different tools. And it took me so long to learn all of that. And then for the training part, to be honest, in industry, DFT trainings are quite expensive. Based on my personal experience, what I have seen, the trainings are quite expensive. A lot of time they will miss basics or something. They will cover like high level stuff, more complex stuff. So if you're a new person, then maybe that training may not help you. So this course also helps new people like who want to get into DFT and memory-based memory testing. So this gives them a good pathway to enter into memory testing. They don't need to jump directly into high level information where they are jumping between different things. Like they're confused, like what is going on. So in this, you will start from scratch, and then I will take you to higher levels step by step. And then DFT is not easy to learn because DFT is super wide area, super big area compared to physical implementation or digital design. So it's not easy to learn for newcomers. For example, you can find a lot of information about RTL design, or learning about, for example, architecture, or if you're learning about, for example, let's say static timing analysis, those kind of stuff, you can find a lot of information online. But if you will try to find the details of DFT, then you will not be able to find much like other areas. So that's why it's pretty hard to learn. And then in organizations, there is no clear pathway. Like you cannot take step by step pathway to learn DFT. You are just rumbling through a lot of different documents, then you open some document and then you go to another document, and then still you don't know what is going on because there is so much information and you need to cover it. So that's why these are few of the motives like which make me develop different courses on DFT. Why you want to learn MBIST, or why we want to learn about MBIST, memory built in self test? If you are a new person like in DFT, then you may know that there are different areas of DFT, like we're testing the logic, we are testing the boundary, and we are testing the memories. These are three main components. So memory is like one of the three major components that we test in the chip. So we need to learn about memory based. It's really important topic in DFT. And the memories are quite big part of chips. For example, you may heard about cache memory, or you may heard about SRAM in the design. So those are all memories. And now like due to latest technologies, we are using a lot of training chips for AI. We have inference chip. So for that one, sometimes 70 to 80% area of the chip is covered by the memories. So it's really important to learn about how memories behave and how we do testing of them. And MBIST knowledge is like really hard to find online. You cannot find a lot of information, especially related to industry. You may find some like theory related materials, but you will not be able to find technical, like which is used in industry. So that's why you need to learn about MBIST. And then the memory testing is like not only responsibility of only DFT team. It's a collaboration between different teams. You will need to talk with, for example, physical team, like where the memories will be placed. Then you will talk with digital designers, for example, like what are the properties of memory, what type of memory. We will see all of these details in this course, like what kind of things you need to take care about. You need to familiarize yourself about memory testing, because a lot of teams, based on my personal experience from digital design or physical backend, they don't know about memory testing, and then the teams will have a lot of problems, a lot of clashes when they are doing the memory based implementation. So this course I hope will be helpful to all kind of engineers. So that's why I have different target audience in my mind when I was making all of this course. And in this course, I have focused first on the fresh graduates or early career engineers, because I used to be that one. And I know how hard it was to be in that stage and trying to find information, asking a lot of questions, lot of details. So at that time, I was having a lot of issues. So that's why, first of all, my target audience is these people. If you're fresh graduate and you're early career engineer, I believe this course will be really helpful to you to learn about memory based. The second group of people which are target of this course are different design teams, different physical design teams, RTL design teams, synthesis teams in an organizations. Because in a IC design house, typically there are multiple teams which are dealing with different parts of chip design. So then these teams, only among them, like only few people will know about DFT. So I want to create more awareness among them, like when they're talking about M-based, what they have to actually think about, what they need to take care of, different things. And then another important is the DFT engineers and flow developers. These are the main target of this course, because flow developers are different from designers, RTL designers, synthesis designer, and physical designers. These are the people who develop the flow, like implementation flow, and then these flows are used by other engineers. So for new people, to give you like overview, like what flow developer do is, they will study all the document, then they will study about different details, they will talk with the tool vendors, they will take care of all the points, and then they will generate a special flow for implementation of, for example, memory based, or we can say like for scan or static timing analysis. So then these people are called flow developers, and then these flows are being used by other teams. For example, to give you example, if I'm a flow developer of memory based, then I will make some scripts, I will make a general flow, and then I will give that flow to a design team, which is actually DFT team. So then DFT team will take care of all of the points that I have mentioned in the flow, and then they will follow my instruction that I have mentioned in the flow, and then they will do MBIST implementation. And then for the graduate students who are still doing study and they cannot find information, about the memory based and design for test, this course is about you. Especially, you can learn the details which are secret for you at this stage, which are like the industrial information which is being used inside industry, which is not provided in other course. So this course is definitely going to introduce you how companies work inside for memory based, what kind of stuff they are looking for in the memory based testing, and what kind of chip implementation flow they are covering, and what kind of implementation flow they used. So I will talk about all of these steps in details in this course. And there are some prerequisites for this course. These are like some must-have skills you should know about. For example, if you are going into memory-based in any organization or you're starting this course, then you should know about digital logic, like what are finite state machines, you know about combinational circuits, you know about sequential circuits, you know about timing details, what is setup time, what is hold time, what are clocks, what is the purpose of clock, what is the purpose of reset. I hope you know these things before starting this course, because then this course will become much more easier to understand for you. And I also recommend that you know about VLSI basics, like what are CMOS circuits, what are the fundamentals of these circuits, and what is the design flow overview, like RTL to GDSI flow. If you know that one, is good. If you don't know about that one, it's okay, because in this course, I'm also going to talk about memory architecture and design flow overview. So, but if you already have that one, then it's well and good. And then you should know about HDL skills, which is like Verilog, system Verilog, RTL coding, and simple test bench generation, because these things are used in the MBIST flow. So for this course, you don't need. But when you're actually doing implementation of MBIST, you need these skills in organization. So if you're preparing for interview, for DFT, or for those kind of positions related to testing, make sure that you have some skills about Verilog, because these will be part of your interview process. And then you should know about DFT foundations, which are scan chains, you know about ATPG and fault models. So these are the some skills you should must have to understand this course, especially related to ATPG basics and fault models. And for this one, you may refer to my other course, which is related to DFT introduction. In that course, I have talked in details about these foundation skills. And then for EDA tools, I will focus on synopsis tools in this course for introduction purposes. But if you know about other tools, for example, from Siemens or Cadence, then it's really good also. So I will recommend like you should know about some of the tools from EDA, like which we use for synthesis purpose. For example, design compiler from Synopsys, and for simulation, VCS, for debugging, Verdi tool. So you should know about these tools, like why we use these tools, at least have some basic knowledge about these tools, and then this course will become much more easier for you to understand. And then you should have some knowledge about scripting language, which is like Tcl or Perl or Python. So a lot of organizations use these three types of scripting languages in their daily life. So if you get good in this one, especially these three, Tcl, Perl, or Python, then it will be really helpful for your career. Okay, now we are moving towards like why this course is different from other courses, or what is special about this course. So in this course, I have included the content which we use in industry, which we use to train TFT engineers, which are being used by different companies. So this is based on my personal experience in different companies. So this kind of content is really hard to find online, especially like related to DFT. So this is the same material that I use personally to train DFT engineers in different companies. And then I have included the practical workflows which are being used in industry again. So I'm again focusing on industry because I don't want you to learn only theory, but I want you to learn how MBIST is working in industry, how DFT is working in industry. So I want you to know about those details. And those details normally are not taught by anyone. And then MBIST is quite complex if you learn from documents, because there is a lot of knowledge and it will be really hard to grasp all of the concepts in those documents. So in this course, I have tried to simplify all of those wordings, those complex definitions, those complex processes. And then this course is developed after like my years of learning. So you will spend few hours into this course, which took me many months to make this course first. And second, I have been gathering that kind of knowledge from many years. So I have tried to put a lot of information into few hours. So I hope in this course you're going to learn a lot, and I wish you best of luck in this course. Here are details about the course contents. So we will first start with the foundation of memory testing. And this is the basic part, which is targeting all type of people. For graduate students, for beginners in DFT, for beginners in MBIST. So we will talk about memory testing, like what is the structure of memory, and then we will talk about how we target different memory structure areas for testing purpose. And I will let you know about different fault types we use for testing of memory and different testing algorithms which target different kind of faults in the memory. And then I will let you know about important feature in testing is memory built-in self-repair, which is called BISR in short. So I will talk about some details of that topic. And then I will give some details about Synopsys star memory system, which is called Synopsys SMS also. So I will share some details about like what is Synopsys SMS system, which is actually Synopsys MBIST solution, and what are the basic components in this one. And then we will go towards industrial side, which will be like how MBIST implementation is done in industry. So in this one, I will share details about different chip design flows like flat flow, hierarchical flow related to DFT, and then I will target specifically MBIST flow for flat and hierarchical designs. And then in the end, I have some extra topics which I will talk about in this course are related to fault injection and memory grouping. So in fault injection, we inject some faults into the memory to make sure that we can repair memory after the chip has been tape out. So this is just a basic introduction. And then in memory grouping, we need to do grouping of different memories when we are testing the memory. I will just give the basic introduction here, and in details, these are all included in the course, in the full course ahead.